Hello everyone, I am Dr. Manish Kumar Bharadwaj from School of Engineering and Technology of IGNOU. Today I will discuss with you IS code method of mix design. This method of mix design is given in the IS code. That is why we are calling it as IS code method of mix design. The Indian standard method of mix design include the design of normal concrete mixes, that is non-air entrained concrete for both medium and high strength concrete. So let us see what are the different steps of this method of mix design. First step is determination of target strength. The target mean strength is given by this formula, which is F target equal to FCK plus K into sigma. What are these different terms in this equation? Let us understand these. Here FCK is the characteristic compressive strength of concrete at 28 days, which is the required design strength. Sigma is the standard deviation to be determined from the test results of at least 30 cubes. Means to get this standard deviation, we have to test at least 30 cubes. The cubes are to be cast and tested, simulating as far as possible the actual site conditions. If such determination of sigma is not possible, then value of it is to be adopted from the table given in IS code 10262. And this table here is reproduced, which gives the suggested values of standard deviation for different grades of concrete, and the standard deviation for different degree of control is given here, like very good control, and fair control. So here you see that from M10 to M60 these standard deviation are given. For example, for M10, for very good quality control it is 2.0, whereas for good control it is 2.3 and for fair it is 3.3. Likewise, you can see for M30, for very good control it is 5.0, then for good control it is 6.0, and for fair control it is 7.0. So depending upon the degree of control for different grades of concrete, different standard deviation value are given in the code as represented here and reproduced here in this table. So these will be used for different grades of concrete. Another table you see, table 2, degree of quality control expected under different site conditions. What are the conditions at site and what is the degree of control? So in case of very good degree of control, what are the conditions of production? That fresh cement from single source is used, regular tests are done, weigh batching of all materials is done, aggregate supplied in single sizes, control of aggregate grading and moisture content is there, control of water added is there, then frequent supervision is there, regular workability and strength tests are done, and field laboratory facilities are there to test various materials. So that way, in that conditions we can say that very good quality of control. Then in case of good control, what is expected? That carefully stored cement is there and periodic tests are done, weigh batching of all materials is done, then controlled water is there, graded aggregate is supplied, occasional grading and moisture tests are done, periodic check of workability and strength is done, and intermittent supervision and is done and the workers are experienced. Then in case of fair control, what is expected? Proper storage of cement is there, volume batching of all aggregates allowing for bulking of sand, weigh batching of cement, water content controlled by inspection of mix, and occasional supervision and tests are done. So that way these are the conditions matching with the fair quality control. Then step 2 is determination of water cement ratio. Water cement ratio for target mean strength is determined from figure 1, which is reproduced from IS code 10262, which you will see just now. The water cement ratio so determined is checked against the limiting water cement ratio for the requirement of durability as given here in table 3, and the lower of the two values is adopted. So let us see what is given in the table 3 and what is given in figure 1, because we will be taking that water cement ratio based on these two, the figure 1 and the table 3. So table 3 here, you see that it gives the minimum cement content required in cement concrete to ensure durability under specific conditions of exposure. What are the different exposure conditions? Then for plain concrete and for reinforced concrete, that minimum cement content is given. So for exposure condition of mild, for example, completely protected against weather or aggressive conditions, except for a brief period of exposure to normal weather conditions during construction. For plain concrete, minimum cement content in kg per meter cube is 220. Maximum water cement ratio is 0.7. For reinforced concrete, minimum cement content is 250 kg per meter cube and maximum water cement ratio is taken as 0.65. For exposure condition of moderate, for example, sheltered from heavy and wind-driven rain and against freezing, while saturated with water, buried concrete in soil and the concrete continuously under water. In such conditions, we call it as moderate exposure. And here for plain concrete, the minimum cement content is 250 kg per meter cube, maximum water cement ratio is 0.6. For reinforced concrete, minimum cement content is 290 and maximum water cement ratio is 0.55. For severe condition, exposure condition, for example, exposed to sea, water, alternate wetting and drying is there, and to freezing whilst wet and subjected to heavy condensation or corrosive fumes. So if such conditions are there, in that case, for plain concrete, the minimum cement content is 310, means 310 kg per meter cube. Maximum water cement ratio is 0.5. For reinforced concrete, the minimum cement content is in kg per meter cube is 360 and maximum water cement ratio is taken as 0.45. So these are the minimum cement content and maximum water cement ratio that may be used for different exposure conditions. This is figure 1, which shows here the generalized relationship between water cement ratio and compressive strength of the concrete. So depending upon that, what is our target mean strength, that water cement ratio may be taken from this graph. Figure 1 is based on a large number of results under Indian conditions depending upon Abraham's rule and is used for initial determination of water cement ratio. Based on this water cement ratio, the mix is designed and subsequently trial mixes are made with this water cement ratio and also by varying this water cement ratio by plus minus 10%. At least 3 cubes are cast for each trial mix and tested for 28 days strength. This strength versus water cement ratio are plotted to get actual strength water cement ratio relationship, which is used finally to design the mix. If, however, the 28 days strength of cement is known, use of figure 2 is to be made in lieu of figure 1 to get more accurate initial estimation of water cement ratio. What is this figure 2? Here you see the figure 2, that is relationship between water cement ratio and compressive strength for different cement strength. So here you see 6 different curves for different 28 days strength of cement A, B, C, D, E, F, and these are the curves for different water cement ratio and 28 days compressive strength. So here from this curve we can read the water cement ratio. Now next step 3 is determination of air content, that is entrapped air. The amount of air content due to not achieving ideal compaction is estimated from table 4 for the nominal maximum size of aggregate used. So here you see the table 4, which gives you the approximate entrapped air content if the full compaction is not achieved. So here you see in this table the maximum size of the aggregate in one column in mm, and in third column entrapped air as percentage of the volume of concrete is given. So for maximum size of aggregate of 10 mm it is 3%, for 20 mm it is 2%, and for 40 mm it is 1%. Now next step is step 4, determination of water content and sand percentage. The water content and percentage of sand in total aggregate by absolute volume are selected from table 5 and 6 for medium and high strength concrete respectively. Means 5 is for medium strength concrete and table 6 is for high strength concrete for following standard reference conditions. Coarse aggregate are crushed, means angular, in saturated surface dry condition, means in SSD condition, and fine aggregate is from natural source and conforming to grading zone 2 of table 4 of IS 383/1970 in saturated surface dry condition. Now water cement ratio of 0.6 and 0.35 for medium and high strength concretes respectively is used, and workability in terms of compacting factor is 0.8. For any other condition, a correction is to be applied on values arrived from table 5 and 6 as mentioned in step 5. So here we see the table 5. It gives the sand and water content per cubic meter of concrete, water cement ratio 0.6, workability 0.8 as compaction factor, and concrete grade up to M35. So here you see in second column the maximum size of aggregate in mm is given, then water content including surface water per meter cube of concrete in kg is given, and then sand as percentage of total aggregate by absolute volume is given. For example, if we are using the maximum size aggregate of 20 mm, then water content is 186 kg per meter cube and that sand as percentage is 35. So that way you can read the water content and the sand percentage values from this table. Here in table 6, which is for high strength, as I told you earlier, the same similar thing as given in table 5, but table 5 is for medium strength, table 6 is for high strength. Again here for maximum size of aggregate, water content and sand percentage are given. Now let us move to next step, step 5. In step 5 what we do? Correction on water content and sand percentage. Here we do. For any other conditions of workability, water cement ratio, grading of fine aggregate and shape of aggregate, then mentioned in step 4, corrections are to be applied on water content and sand percentage as determined from table 5 and 6. The corrections to be applied are indicated in table 7. So let us see what is table 7. Table 7 gives the corrections to be applied on water content and sand percentage for other conditions. In first column, you see the change in condition stipulated for table 4 and 5, and in next column you see corrections required for water content and also for percentage sand in total aggregate by absolute volume. For example, for sand conforming to grading zone 1, 3 or 4 of table 4 of IS 38379, water content correction is 0, whereas sand percentage correction is plus 1.5% for zone 1, minus 1.5% for zone 3 and minus 3% for zone 4. So likewise, for different conditions you can read these values of correction in water content and correction in percentage sand in total aggregate by absolute volume, and these corrections will be used if conditions are differing. Now let's move to the next step, which is step 6. Calculation of cement content. The cement content is calculated from the water cement ratio and the final water content arrived after adjustment or corrections. The cement content so calculated is checked against the minimum cement content from the requirement of durability that is given in table 3, and the greater of the two values adopted. Now let's move to next step, which is step 7. In this step what we do, we determine the fine aggregate and the coarse aggregate content. So with the quantities of water and cement per unit volume of concrete and the percentage of sand in total aggregate by absolute volume already determined after applying corrections, that is in step 4 and step 5, the coarse and fine aggregates content per unit volume of concrete are calculated from this equation as you see here. This equation gives the volume of entrapped air in fraction equal to W plus WC upon SC plus 1 by P into WF upon SF into 1 upon 1000. And volume of entrapped air in fraction is given as W plus WCE upon SC plus 1 upon 1 minus P into WC upon SCA into 1 upon 1000. Here, let us see what are the different terms. W is the weight of water, means that water content in kg per meter cube of concrete as determined through step 4 and 5. WCE is the weight of cement in kg per meter cube of concrete determined through step 6. P is the ratio of fine aggregate to total aggregate by absolute volume determined through step 4 and 5. WF and WC are the weight of fine aggregate and coarse aggregate respectively in kg per meter cube of concrete. And SC, SF, SCA are specific gravities of cement, fine aggregate and coarse aggregate respectively. Now let us see what is the next step, that is step 8. In step 8, what we do basically, we apply correction due to absorbing or moist aggregate. Because if you are using moist or absorbing aggregates, then we have to apply correction for the water. So aggregate due to long storage at open place may lose moisture or acquire moisture. So concrete mix design is carried out on saturated surface dry condition aggregates, that is SSD aggregates. Means we are assuming that we are using the SSD aggregate. So with that assumption we are doing the concrete mix design. These aggregates will neither absorb moisture from mixing water nor they will have any excess if we are having the SSD aggregate. Hence, they do not disturb the mixing water, or in other words, the water cement ratio is not disturbed if we are using SSD aggregate. If on the contrary aggregates are absorbing type, then it will absorb moisture from mixing water to attain SSD condition. Hence, in such condition, extra water is to be added with mixing water to maintain the water cement ratio constant. It is also mentioned that WF and WCA, that is weight of fine aggregate and weight of coarse aggregate, calculated in step 7 is for SSD aggregate. Hence, a negative correction is simultaneously to be applied to the weight of aggregate. The magnitude of correction will be equal to the weight of extra water to be added with mixing water, that is the amount of water the aggregate is going to absorb to attain SSD condition. In case of moist aggregate, the correction will be reversed. This correction is to be applied each time to the mix proportions calculated in step 1 through step 7. Moisture condition of aggregate available at site is to be determined. Now let's move to the next step, which is step 9. So after doing step 1 to step 8, what we have done, we have fixed the amount of different ingredients of the concrete. And now we will go for, in step 9, we will go for the trial mix. So the calculated mix proportions shall be verified by means of trial batches. What we will do, quantities of materials worked out in accordance with various steps, that is from step 1 to step 8 mentioned here, shall comprise trial mix number 1. The quantity of materials for each trial shall be sufficient for at least 3 150 mm size cube concrete specimen and concrete required to carry out workability test according to IS code. So means we should have enough quantity of material, because we have to cast at least 3 150 mm size cubes of this concrete, and we also have to do the workability test. Workability of trial mix number 1 shall be measured. The mix shall be carefully observed for freedom from segregation and bleeding and its finishing properties. If the measured workability of trial mix number 1 is different from the stipulated value, the water content shall be adjusted according to table 7 corresponding to the required change in compacting factor. So this is to be done here. Very important step. With this adjusted water content, the mix proportions shall be recalculated keeping the free water cement ratio at the pre-selected value, which will comprise trial mix number 2. So after adjustment, we'll go for trial mix number 2. In addition, 2 more trial mixes, number 3 and number 4, shall be made with the water content same as trial mix 2, but varying the free water cement ratio by plus minus 10% of the pre-selected value. For these 2 additional trial mixes number 3 and 4, the mix proportions are to be recalculated for the altered conditions of free water cement ratio with suitable adjustment in accordance with the table 7. The values given in table 7, that is to be referred. 28 days compressive strength obtained by testing cubes cast with mix 2 to 4, means these trial mixes 2, 3, 4 are plotted against respective water cement ratio and a smooth curve indicating a realistic relationship between 28 days compressive strength and water cement ratio is obtained. So using this relationship so obtained, any change needed in water cement ratio to get the required target compressive strength may be easily obtained. The concrete mix proportions shall however be recalculated for this changed water cement ratio. Means each time if there is any change in the water cement ratio, then we have to recalculate the concrete mix proportions again and again whenever there is a change in the water cement ratio. So this way we saw that what are the different steps for concrete mix design as per the IS code method of the mix design. So based on these steps, we will go for concrete mix, and in next lecture I will give you an illustrative example that based on this method how we can design the concrete mix. So thank you for watching.